Making sense of rounding and significant figures. In this lesson we'll look at how to round numbers, what significant figures are, and how to do calculations involving significant figures. We use rounding in everyday life all the time in such things as estimating the size of a crowd or paying for goods. This motorist buys 57 litres of petrol at 159.9 cents per litre. So how much does he actually pay? To find that out, we multiply the 57 litres by the 159.9 cents per litre to get 9,114.3 cents. This is rounded off to $91.14 if we're paying by FPOS, or $91.15 if we're paying by cash. Now we've got to be careful to do our rounding off only at the end. If we were to round our 159.9 cents per litre to 161st and then multiply it by 57, we'll be multiplying that difference by 57, which is not so important in this example, but for larger volumes it will make quite a difference. Let's see how we can round that off on a scale. We have 9,114.3 cents, and we can see that that's closer to 9,114 than it is to 9,115. Here we're rounding off to the nearest cent. Let's do the same thing now in a dollar scale. So we mark our $91.43, and once again we can see that we are closer to $91.14 than to $91.15. When should we round up and when should we round down? 9,114.5 is exactly in the middle, and so anything above that we should round up. Anything below we should round down. Now really the 0.5 is exactly in the middle, although we tend to round up with that one because if there is another digit after the 5, we're definitely over that halfway mark. On the dollar scale, that comes out to be $91.145. So the rule of thumb is that we look at the digit after the decimal place we want to go to, and if it is 5 or more, we round up. If it's less than 5, we'll round down. We are asked to round 3.456 to two significant figures. We need to ask ourselves, is 3.456 closer to 3.4 or 3.5? We need to look at the next digit along, which is 5. That means we are at least halfway, so our answer needs to be rounded up to 3.5. Significant figures indicate how precisely we've made our measurements. Given a 100 centimetre ruler, how long do you think this line is? We could possibly estimate it to be about 30 centimetres. How long do you think it is now? We could measure this a little bit more precisely now, perhaps to 27 centimetres. And given a more precise measuring instrument, we can measure that more precisely once again, possibly even to 26.8 centimetres. We can more confidently measure that now to 26.8 centimetres. The 26.8 centimetres is more precise than the 27, which is again more precise than the 30. 30 is to the nearest 10. It has one significant figure. We only know the tens digit. 27 has two significant figures because we know the tens and units digits. And 27.8, we know to the nearest tenth, has three significant figures because we even know the tenths part of it. So how many significant figures will a number have? Well, it's generally just the number of digits, but we have to be careful with zeros. Leading zeros are not significant, so this number has two significant figures only. Imagine if this was the length of a line in meters, then we have measured this to the nearest millimeter, 23 millimeters, which clearly has only two significant figures. Trailing zeros after a decimal point are significant. Again, if this is a measure of a line in meters, the zero at the end tells us that we've measured the line to the nearest millimeter. Zeros in between other digits are significant, so that number has four significant figures. And zero at the end of a whole number may or may not be significant. We don't really know unless we have more information. 5,000 may have been measured to the nearest unit, or 10, or 100, or 1,000. We don't know. If we aren't given any further information, we err on the cautious side and say that that has only one significant figure. We cannot make a number more precise simply by doing a calculation. Let's see how significant figures work when we're adding and subtracting numbers. I have $34 in notes and along with some coins in my wallet, and I have $22.25 in my pocket. How much do I have altogether? Well, to find that out, we add the two numbers that we've got, and we get $56.25. However, the $34 is to the nearest dollar, whereas the $22.25 is to the nearest cent. And so I can't really answer to the nearest cent. I need to answer to the nearest dollar only. So I'll quote my answer as $56. When we're adding or subtracting, we think place value. The answer has the same place value as the least precise number being added or subtracted. The underlying principle when multiplying and dividing is that you can't make a number more precise by doing a calculation. That's the same principle as in addition and subtraction, but the details are a little different. Let's have a look at an example. How far does a car travel in 4.2 seconds if its speed is 3.45 meters per second? Well, to work out the distance, we multiply those two figures, the speed times the time, and we get 14.49 meters. Now 4.2 has two significant figures, so our answer can't be more precise than that. Our answer should only have two significant figures. And so we'll quote our answer as simply 14 meters. When multiplying or dividing, think significant figures. The answer has the same number of significant figures as the least precise number. To round off a number, we look at the next decimal place, and if it is 5 or more, we'll round up, otherwise we'll round down. When we're doing calculations, we can only quote our answer as precise as the least precise measure in the question. Now, when we're adding and subtracting, we need to think decimal places. But when we're multiplying and dividing, we need to think significant figures.